This one's negative L, right? Multiply by -1, you get this one. So it doesn't matter whether they start positive and go negative or start negative and go positive. If it converges one way, it converges the other way because they're just the opposite signs. So we don't write it like this, we write it like this. And we'll always write them in this standard form where this part is positive so that it's not, so you don't get confused. Make your terms always positive and then put the alternating part out in front. This one starts with a negative, right? This was negative A1 plus A2 minus A3, dot, dot, dot. And so you'll also see this with a +1 or a -1, right? It doesn't matter which. And all that does is make it start. Put 1 in there, I get a positive. A1 minus A2 plus A3 minus A4. Dot, dot, dot. So that's what alternating series are.
Base of import's always positive.
Pardon?
Base of import.
Yeah, it's just a convention. I could make it negative. I could write the sum from n equals 1 to infinity of -1 to the n times -1/3 to the n. It's just confusing though. What's the advantage of that? Let's write it out. What is this? This is if I put 1 in, I get negative. If I put 1 into here, I get -1/3. Then I put 2 in, I get positive, and then I get positive 1/3, right? No? 1/9? No? If I put 2 in?
Yeah.
Okay. If I put 3 in, I get negative here, and then a negative times negative times a negative is a negative 1/27. So what I have is 1/3. Oops, this one's nasty. Plus 1/9. This one's not an alternating series. Did I do something wrong, or am I right? Positive, positive, negative?
It should be positive, all
Yeah.
positive.
Yeah, it should be positive.
Because it's-
27.
This was negative, and this was negative.
Negative.
That's positive. So this one's positive, and the 1/27th, the third time I put a 3 in there, that's negative. Oh, and that's negative. Right. So see, now you see why we want these terms. Even I get confused. I want all the terms positive because now it looks like an alternating series because this, but it's not even an alternating series, right? So yeah, we always want this part positive so that it's obvious this is the only part that changes signs, so that it truly is an alternating series, and you can easily tell by whether it's n or n plus 1 or n minus 1 whether it starts with a negative or starts with a positive. Now if you look at the alternating series test, there's 2 tests. One is the absolute convergence test, which says, suppose I'm looking at this one. It says that if you throw the negative part away and it still converges, then the alternating one converges. So it's the nicest test in the world. It says ignore this part first. Does that converge? Yeah, it's a geometric series, right? So the alternating series test says if the sum from n equals 1 to infinity of the absolute value converges, then the sum of the a sub n converges. Oh, sorry. Put the negative back in the kid. So that's the only one I have time to talk about today, but this one says if you want to, and you can just take the absolute value of it, and you know that's a series that converges, then it converges when it alternates, which kind of makes sense, because you got a whole bunch of things added up, and it converges with all pluses, and you make every other one negative. What did you do? You shrunk it, right? You took half of it away. Maybe not half of it. But if you make every one of them negative, it makes sense that it would still converge because you're taking some stuff away. Okay, so that's what the absolute convergence test says. It's very easy to use. Okay, stay off the street. I'll see you.